Hey Ed, this is Shravan. This is my demo for this PA. So this is Milestone1, the converter and the viewer. So inside of my engine directory, there's an FBX converter exe folder, which contains all the models and the textures that I'm going to package. So I'm going to run the convert all models bat file. And while it cooks on, just to let you know, we are using the FBX files along with their associated textures, and I can support up to 2 textures per model. So for Warbear, there's a special T2 flag that captures both the Warbear and the polar bear. So the clean me removes the binary and the BLO files. The clean all removes the SVU files as well. So while this is cooking, almost there we go. So now that this is done, I'm just going to grab the SPUs that we generated. This should be done by a batch file also, but I don't know batch very well. All right, so I'm just going to put them here and then come back to my engine. If everything worked correctly, we should have our demo. So this is cooking, still cooking, still cooking. Yeah, we're almost there. We're almost there. And in the meanwhile, there's like a bunch of cameras that I've put in here. So I had a new orbit camera that you can focus around an object and then sort of orbit it. And then the normal front and top cameras that just like you can just move around with them. You can't necessarily focus on anything. All right. So this is how we kick off with the tropical fish. No better way. With this camera over here, I can sort of move around it, drive around it, using the arrow keys. Use I to zoom in or to zoom out. You can already see that we have a tropical fish, a frigate. There's that alien model. And then there's Astroboy. There's a rotating polar bear. There's a rotating war bear. There's another space frigate that is rendered with lighting. And there's a buggy in the distance. So if I press the C key, I can cycle between my cameras. So you can see that. Oh, that's kind of cool. You can see that rotation between the war bear and the polar bear. Oh, that's kind of cool. Okay, so we can see both of these, and so that's model instancing. I press another C. Now we're really close to the war bear. We can move around it, do funny things. We have the Astro Boy, and there's the default texture, which I'll show in a minute. Here's Astro Boy. Here's a nice scene. I think that has everything. That's a pretty decent angle. There's the space frigate, and there's the buggy. Alright, that's a pretty decent angle to show everything. So if I've hit the space key, we have bounding volumes, and they're in this nice rainbow color because I sort of like it. And there's like a nice sort of solar system-y kind of feeling about this. So if I continue to cycle between them, I can cycle through all the cameras, zoom in and out. So you can see that we have all the models from all the 4 groups, plus of course the space frigate, and you can see that the bounding volume is sort of updating as those war bears and polar bears are moving. Yeah, that's the fish. That one's for you. So one thing now, which is going to be fun, the last thing that we need to sort of demo. Oh, this is the alien, by the way. This is the Group T 1000 volt or higher model. For texture swapping, I sort of left it the way that I did last quarter. So if I hit the T key, there's going to be some fun bit happening because we're going to cycle through all the textures for all the models. That should be fun. So if I hit it, there you go. Now you have 2 very interesting pairs, and again and again and again, and now we're back. So I have been trying to challenge myself. There we go. So now the war bear and the polar war bear's texture has been swapped nicely, and if I hit it enough, we'll get back to the originals. This is, by the way, happening with all of them. So if you want to see some really creepy stuff, there's a metallic Astro Boy, there's a tropical fish Astro Boy. I don't even know what that is, and the default texture thing. So that hits sort of the requirements of all the that fish was originally rendered to show the default texture, which is why it doesn't have a bounding volume there, that fish there. So if I hit the T key there, that's the one that had the default, and you can see that all the others have gone back to their original textures. So in terms of the demo and the requirements, I think that's pretty much it. So let's go through the code. So for the converter, like I said, I'm packaging the textures as well as the bounding spheres. So most of like getting the FBX data, so the words and the tries, are I sort of almost left it the way you convert it. So inside of these 5 vectors, and I have an FBX packager class that then takes all these vectors and accordingly creates chunks. So chunks for a vertex, trilet, and bounding sphere, and then uses LIU to link all of them up to create the SPU. So inside of the main, you can see that there's this slight command line parsing going on here, where based on whether there were textures included, we have the texture packager create the appropriate chunks. So inside of here, now the one thing that I don't really like about this is to make sure that the textures get parsed and get loaded properly. I had to replicate the texture manager's enum inside of here, and this isn't that great because this exactly has to match up with the one that's in there. So every time I add a new texture, I had to add a type here and then add one inside of that, which was not fun. Once you do have them though, what you can do is basically I have them hooked up to the texture names. So this comparison happening inside of the converter I thought was better than doing it in the model. And once I have this, what I do is I simply just first slam in the type and then write that TGA to a binary. And when I do that, I immediately just once I write the binary TGA, where is it? I just invoke vodka somewhere. There we go. So get texture type. I should have done that before. Write the binary file and then use vodka to create the chunk. And for the FBX packager, in a similar way, we create the words chunk. So just process the correct vector and sort of just write it in there. Create the trial chunk, same way, and then create the bounding sphere chunk. So what we do is we've already processed inside of this vector all the words of that model. So we create a return sphere from here, and once we compute the radius and the center, we construct a bounding sphere and just immediately write that sphere into its own chunk over here. So that's sort of how the FBX packager in the end just ends up linking everything together once it's created stuff. So that's what's happening there. Inside of the viewer, like I said, we have a bunch of cameras that are conveniently placed to look at different models. I'm loading the SPU files over here. So you can see that there's absolutely now the only TGA that we're adding explicitly is the hot pink. And other than that, everything is being taken care of by the FBX models. We have bounding sphere objects over here, which again, the structure mimics the bounding sphere object that I have from there. So I'll just go to the FBX model class because this is like the one that does everything. So in the priv create VBO, I beg your pardon. So we can just use the eat function. So I imported the eat function from PA1. You can just eat the words we assign trilist bounding sphere and then use it for the texture manager. So just to sort of I created different chunks for this assignment, and then a decision to sort of have this as one big chunk as opposed to separate chunks was that the layout is what OpenGL sort of expects. If you do the little bit of swizzling down here, so we already had that. So taking it as one chunk avoids looping through and finding, getting all those files inside of the engine, because all of it is already in the right format. So then it's just easily loaded it and just fed in over there. And then the last thing, just to get the textures, I added a second eat function that actually can load two chunks of the same type, so it doesn't break when it finds one. It continues on and looks for a second one. So it's just the same thing, but it just, instead of finding one, it finds two. And I don't know how I got it. Yeah, all right. So once we had that, we have the TGA buffers and the TGA size. So we pass in. I have a new function here called add FBX texture, which basically just passes in the texture name and the pointer to the TGA bits, and then mimicking how we used how we loaded TGA bits before, we sort of do the same thing, but the only thing is we don't need to now read the TGA file because we already have a pointer to all the bits. So everything else is pretty simple. We just have to cast that buffer, the beginning of that buffer, to a TGA header, read all the info from there, and we're done. In terms of the bounding sphere, it's a pretty similar layout to what you did in class. We have a simple game object and a bounding sphere game object, and the simple game object first updates the bounding sphere, which will use the reference sphere that we loaded from the model, and then do a bunch of math, and then uh, get the update the current one. This sphere over here is then used by the bounding sphere, and accordingly it adjusts then adjusts its graphics object, and that's how it renders it. Finally, to toggle the bounding spheres or not, I just added a simple boolean to the game object manager, which we control when we do the space and the tab, and then I check for that in the draw function of the bounding sphere game object, and accordingly render it or not. So as far as like code review stuff is concerned, I sort of like the fact that I was able to support textures and bounding boxes and do everything in the converter and then just export it into the model. I definitely don't like the sort of dependency that I have with the particularly with the textures over here. This enum has to be exactly the same and has to be updated everywhere. In terms of the viewer, one thing I was noticing was that it might be better to have a game object construct its bounding sphere as opposed to constructing them separately and then attaching them to game objects. So I might explore that part next, and because we have to create them and then attach them to game object, which we are doing, but it might, since game object will probably have a bounding sphere, it might be better to sort of have the game object construct its bounding sphere as opposed to, the other way, as opposed to having both of them outside and then sort of linking them up. Then one more thing that I think I had something else also, which I didn't. Oh yeah, since we're almost always going to export textures using the model, we could somehow have the models manage the textures themselves as opposed to using the texture manager to find them and get them. And we could simply pass, when we create the shaders, we could simply use the textures based on the model, that when we create the graphics object, so we can use the textures from here inside of the shaders. So there's just a couple of things that we could do, but overall I think, yeah, my converter is definitely not as stable as I'd like, so I need to figure that out a little bit, like investigate a little bit more. But other than that, I think that's it. I'm going to call this video done. Thanks for watching, and yeah, see you for the next one. Cheers.